Electrons flying around a nucleus should emit radiation and eventually lose energy. Because of this, we believe that they don't do that, because we know that they don't fall into the nucleus. They do emit radiation, however, but they also absorb radiation. They absorb it from the proton and emit it passively like protons do. This is why low-energy electrons are closer to the proton and higher-energy electrons are farther away from the electron. This is why low-energy electrons are closer to the proton and higher-energy electrons are farther away. They emit a stronger radiation and so repel themselves farther away from the nucleus. This means the electrons are getting less energy from the nucleus, though, and so they eventually use/emit enough that they cannot sustain themselves, but also can't get closer. This is when they emit photons to jump down to a lower level. Basically what I'm saying there is that an electron gains energy, moves up, and because of that, it repels itself farther away from the proton. But by doing that, now it's stuck out here at this higher energy state, but then it starts to lose its energy and it goes, oh no, I want more energy. I can't get more energy here. It's repelling itself too strongly to get closer. So it has to emit energy up. It has to dump energy out so that it emits less energy and it can move closer to the nucleus. And that's what we see as these, the electrons jumping around. I don't think, I think the common belief is that electrons are just kind of jumping from state to state. There is no in-between. I don't think that makes sense. I don't think that's logical. The fact that we can't even really pinpoint where an electron is going to be even points to that being even less likely. When you get more and more electrons around the nucleus, and things start to get even more complex, because not only do these electrons have to deal with the emission from themselves versus the nucleus, but they also have to deal with the emissions from themselves and the other electrons within the nucleus. And so that's why we get these cloud structures, because the electrons kind of all emit on each other, and so that's why we end up with these seeming perfectly displaced kind of clouds where we think the electrons should be, because they all are repelling each other and they find this kind of balanced area, but things are always in flux, right? The electrons are always kind of moving depending on if they get more energy. Oh, they got a little more energy, that adjusts where they're going to be. Oh, they lost energy, that adjusts where they're going to be. So they're never staying stagnant, so they're always in fluctuation, but they're always counterbalancing each other. They moved a little bit closer to this one. Oh, well, there's a repulsive force because of this one's emitting radiation and this one's emitting radiation. And so they're always kind of fluctuating in these clouds, but these clouds are relatively where we find them, because that is the relative area that is equidistant, and so they all stay within that range of a zone. And why you can have two in an orbital is because one electron is kind of, in theory, I'm not 100% certain on this. I guess I have to dig back into this more. But my current belief is that, one photon, it's the spin up and spin down. One is sending out radiation. The other one is more on a consumption basis, right? So, they hang out together because one of them is up absorbing energy that is being put out from the other one. And so they don't repel each other away, and they can kind of hang out and be buds. And then when this one is done absorbing and starts to send energy out, right, then this one changes over and starts absorbing. So they're kind of in this back and forth balance. And so that's why they hang out in a pair when possible, but they don't hang out in triplets, because then they're not, then there's no balance there. And they would repel, right? So, that's what's that's what's making that mechanic work. And I don't think that was all I wanted to say. Let's see. So another thing I want to say is that when a photon is emitted from these electrons around a nucleus, it is also potentially a mechanic to help I put to help punch down to the closer orbitals, but I'm not so certain to kind of help punch through the other effects from other electrons and the proton. But I don't think that it's necessary, actually. I think yes, but it's not that sending off this photon is jettisoning the electron closer to the nucleus. I think it's more that because energy has been released, right, its mass I mean, it really comes down to gravity, but its mass has been reduced, so it gets pulled closer in, and then because of that, it doesn't really need to worry about everything else, right? It just kind of gets pulled in, and then when it gets more energy, then it starts to flow back out again. And that's really just a mechanic of momentum conservation, sort of. It's going to take more thought for me to iron out and be confident in the mechanics of what is causing that repulsive and attractive force on a more simplistic level. I think it has something. My goal is to tie everything back to dark energy and the absorption of energy, basically. Gravity, because that's what gravity is. But I'm not. I don't have that figured out completely in my head, so I'm going to leave it there for now. But what did I start with on this? Yeah, basically, this whole explanation is to tie back to the logic that electrons should and do emit radiation, and they should fall into the nucleus, but they don't, not because they don't emit radiation, but because they're constantly also absorbing radiation to sustain themselves, right? So that's why we end up with the behavior that we see. Anyway, that's that for now. I will have to come back to this so I can explain the repulsive force more thoroughly, but I have to work on that. So give me a day or two. Anyway, peace out.